Let me introduce myself. I am Dr. Patrola Madhusudhan, Department of Chemistry, B.V. Raju, Institute of Technology. Course name Engineering Chemistry. I am going to discuss classification of fuels and calorific value. So, fuel. Let me define what is fuel. Substance undergoes combustion in excess of oxygen. It will get converted into delta H. So, under prerequisites, let me ask one simple question, basic question. What is fuel? We can define easily, keeping this reaction in mind. This substance easily can be burnt in excess of oxygen and liberates large amount of heat. This substance is called fuel. Next question, let me ask under prerequisites, what are the components present in fuel? So, reactants during the process of combustion, what are the reactants we have? Substance plus CO2. What are the combustion products? CO2, H2O, vapor. So, it means this substance composed of carbon and hydrogen. So, any substance which undergoes combustion and liberates large amount of heat, along with this heat, liberation of CO2 and H2O vapor also takes place. This substance is known as fuel. Right? Fuel is mainly composed of carbon and hydrogen. During the process of combustion, outer cell electrons of substance, outer cell electrons of carbon, hydrogen and oxygen undergo rearrangement. Because of rearrangement, after complete combustion, in presence of oxygen, liberation of heat takes place. Therefore, all fuels being used for domestic and industrial purposes is the best energy resource. So, another name for this chapter is energy resources. Right? Fuel. Let me define it again. Any substance which undergo combustion in excess of oxygen liberate large amount of heat along with the combustion products CO2 and vapor is known as fuel. Fuel mainly classified into two types based on their abundance. Right? Primary fuels, two secondary fuels, based on their availability or abundance, secondary fuels, right? Further, based on their physical state, primary fuels classified based on their physical state. Primary fuels further classified into three: solid fuels, liquid fuels, gas fuels. Right? Example under solid fuels, we know, all of you know very well. Primary fuels are also called natural fuels. They are abundant in Earth's crust. So, these fuels are called natural fuels. Based on their physical state, further classified into solid fuels, liquid fuels, gas fuels. What are the natural fuels which are in solid form? For example, wood. Wood is a combustible substance composed of hydrocarbons. It can be burnt, also liberate large amount of heat. When you compare with the liquid and gaseous fuels, the amount of heat liberated less. Okay, that is different. We will discuss it later. Under natural fuels, based on the physical state, liquid fuels, natural liquid. What are the natural liquid fuels which is abundant in Earth's crust? Crude oil. Crude oil. So under natural gases fuels. Example, the above crude oil, what we get above crude oil, natural gas. Like secondary fuels also. Fuels which are derived from primary fuels are called secondary fuels. Derived from primary fuels are called secondary fuels, right? Further, based on their physical traits, these are also classified into three types: solid fuels, liquid fuels, and gas fuels. So these fuels derived from primary fuels. Example under secondary solid fuels. So we can wood. After partial combustion, we get coal. Source of coal mainly wood, right? Coal, right? So we need coke for metals in medicine. You cannot use coal; it contains less carbon content, low calorific value comparing with coke. So coke which can be derived from coal. Source for coke is coal. Source for coal is wood. Therefore, these two derived from this wood, right, are called secondary solid fuels. Liquid secondary fuels. What are the liquid secondary fuels? What are the fractions, important domestic fuels that we derive, secondary fuel that we derive from crude oil, petrol, kerosene, diesel. Petrol, kerosene, diesel oil. Gas fuels. Under gas fuels, secondary gas fuel. What are the secondary gas fuel that we know, that we extract from natural gas? All compressed LPG, CNG, and other gases. Combustion reaction is exothermic. Any reaction liberates large amount of heat. That reaction is called exothermic. So all combustion reactions are exothermic. All fuels undergo combustion in excess of oxygen. All fuels can be burnt in excess of oxygen because fuels composed of hydrocarbons can be burnt easily, and during the combustion of process liberate large amount of heat, right? This liberated heat content can be measured in terms of its calorific value. So amount of heat liberated in any combustion reactions. Fuel composed of carbon, hydrogen burns in excess of oxygen, liberate CO2 plus H2O vapor plus heat, delta heat content. This heat content can be measured in terms of its calorific value. Calorific value classified into two types: gross calorific value to net calorific value, right? Gross calorific value, net calorific value. So we need to define what is calorific value. So we know very well this reaction is exothermic, heat liberation takes place. Amount of heat, and this value we need to express in terms of its calorific value. Can be classified into two types. And here latent heat of vaporization also there. In the combustion reaction takes place in open system. When we use fuel in two-wheeler, four-wheelers, so it is that reaction is called, we utilize only delta H, only net calorific value. We utilize only net calorific value. we never practically it's not possible to utilize gross calorific value because vapor is a gas. Vapor escapes along the carbon dioxide through the silencer. We discharge into the lower atmosphere. We utilize to run the vehicle only delta H, net calorific value. So that calorific value is called net calorific value, and excluding gross calorific value. Excluding gross calorific value, amount of heat. Let me define first what is calorific value. An amount of heat liberated when 1 unit mass of fuel burned completely. Calorific value can be defined when 1 unit mass of fuel burnt completely in excess of oxygen, in excess of O2, heat, amount of heat liberated when this can be classified into gross calorific value. Gross calorific amount of heat liberated when 1 unit mass of fuel burnt, including latent evaporation. This also included. So if the reaction takes place in the closed container, the heat energy and products also not all. You take any fuel, solid fuel, allow it to burn completely after supplying oxygen. So H2 vapor also there inside. It's a completely closed, detached from surroundings. No chance escape. It's a closed system. If you want to measure calorific value of any fuel, solid fuel or liquid fuel, so like using Bob calorimeter, they are completely detached with surroundings, closed system. Neither heat energy nor combustion products allowed to escape. So in that condition, we can measure total calorific value. So after some time, when it's cooled to room temperature, again this H2O vapor condenses into liquid. Vapor condenses into liquid. During the conversion, liberation of heat takes place, including that heat. This heat is called latent of vaporization. Latent heat of vaporization. Including this latent of vaporization, gross calorific value can be defined GCV, gross calorific value, net calorific value, NCV. GCV can be defined total amount of heat liberated when 1 unit mass of fuel burned, when 1 unit mass of fuel burned completely in excess of oxygen. Amount of heat liberated when 1 mass of fuel burned in excess of oxygen includes latent of vaporization. This can be possible when fuel allowed to burn in a closed system like Bob calorimeter. We can measure vapor, that heat content present in vapor. Right. So after some time, when closed system cooled to room temperature, vapor condenses. During the process of condensation, it liberates heat. This heat is called latent of condensation or latent of vaporization, equivalent to latent of condensation. So GCV can be defined as total amount of heat liberated when 1 unit mass of fuel burned completely in excess of oxygen, which includes latent of vaporization or latent of condensation. Right. Net calorific value, same definition, excluding latent of vaporization. So net calorific value can be calculated GCV, gross calorific value, minus into H by 100 into 587, where H is a percentage of hydrogen present in fuel. We know initially I told fuel mainly composed of hydrocarbons. Of course, sulfur also there. When you compare sulfur content with carbon hydrogen, less. Sulfur also combustible sources. Main components present in fuel are carbon and hydrogen. So we can calculate this value. How to derive this formula? Very easy. And during combustion purpose, you can divide this reaction into two. Carbon combined with oxygen produces carbon dioxide. One reaction. Carbon combines with oxygen, convert into how to derive this formula. This right, net calorific value is equivalent to net calorific value. This equal to latent of vaporization or condensation. This value. So this, how to get this? During combustion, you can divide this reaction into two halves. One reaction, carbon converts into carbon dioxide. Second reaction, H2, not H2, HS, hydrogen does not exist in H2 form. Any fuel, you take petrol composed of C5 C6 C8 carbons, hexene, heptene, octane, maybe saturated, unsaturated. So carbon in chain length may be 6 or 7 or 8 hydrogens attached to the chain like this. So for our convenience, I'm writing like this: H2 plus of O2 gives rise to H2O vapor, H2O gas, vapor or gas. So very sorry, gas. During combustion, 2 grams or 2 parts converts into 18 parts. 1 part of hydrogen converts to 9 parts. 2 parts of hydrogen combines with 0.5 part of oxygen produces 18. 2 grams of hydrogen combines with half mole of oxygen produces 18 grams of H2O vapor during combustion reaction. Right, like 1 gram or 1 part produces how much? 9. This is 9, where hydrogen is equal percentage. 587. Let me explain what is 587. During combustion, H2O vapor liquefies, condenses. During combustion, if it is 1 gram of H2O is there, H2O vapor is there, it produces equivalent to 587. Or if you want to liquefy H2O liquid into H2O vapor 1 gram of H2O liquid, 1 gram of H2O liquid. If you want to vaporize, how much of heat you need to supply? You need to add heat about 587. This amount of heat required is called vaporization. If the reaction takes place combustion in a closed container, equivalent amount liberates, almost equivalent amount liberated is equal to 587 calories. Like this is 587. This is a formula we use for calculating net calorific value. We can also calculate gross calorific value using Dulong's formula. Calculating calorific value GCV using Dulong's formula. This formula also called theoretical formula. Okay. Dulong's formula is equal to 1 by 100 into sum of the percentage of carbon, hydrogen, sulfur mainly. Carbon, hydrogen mainly, negligible content sulfur also percentage, and then calorific values and their delta Hs, amount of heat liberated, right? So calorific value of the fuel. So it means fuel mainly composed of carbon and hydrogen, negligible amount of sulfur, because sulfur also combustible substrates. Sulfur also liberates heat after combustion, right? Sulfur during combustion, carbon converts into carbon dioxide. Already we discussed it. And hydrogen attached to the chain. So our convenience, I'm writing like this: converts into H2O vapor, and S converts into SO2. All liberate delta H. All reactions are exothermic. Delta H. It also contributes, right? Of course, sulfur dioxide is highly poisonous when you compare with carbon dioxide. That is different. But reaction is exothermic. Sulfur combustible converts into sulfur dioxide and also liberates heat. So let me write in formula: 1 by 100 heat content during combustion. Liberated heat equal to 8080 calories per gram. Here during combustion, H2 converts into H2O vapor. Liberated heat equal to 34,500 calories or kilocalories. Calories or kilocalories. During combustion, sulfur converts sulfur dioxide. Delta H, liberated delta H equal to 2,240 calories or kilocalories. If it is 12 grams, liberated equivalent to this 8,080 calories per gram. If it 12 grams, liberated heat is called 8,080 into 12. If it is 12 kg, liberated is called 8,080 kilograms into 12, right? 1 kg of carbon, when it is burnt in excess of oxygen, liberated is called 8,080 kilocalories. If it is grams, calories, like this. So let me write first which one is there. Let me write first main component in the fuel. Main content in the fuel is carbon. Its calorific value, how much? Carbon 8,080 into carbon percentage place sum. I mentioned here sum. You can put in the brackets, no problem, instead of into, right? Plus next hydrogen calorific value 34,500. If let me explain again. 34,500 calories per 1 gram. If 1 gram of fuel burned, liberated 1 gram of hydrogen burned, liberated is equal to 34,500, right? 2 grams are there. 34,500 into 2, like that. So into H. So already present oxygen may be there in the fuel. We need to subtract. If already present oxygen is there, this combines with oxygen. Already present oxygen converts into H2O vapor, H2O gas. So for this heat energy required, whatever amount liberated, it will utilize that heat if already present oxygen is there, not atmospheric oxygen, outside oxygen that we are supplying for combustion. If already oxygen is there in bonding, during combustion, breaking takes place, rearrangement of electrons takes place, and hydrogen combines with already present oxygen and get converted into H2O gas or vapor. For this, heat energy is required. So whatever amount liberated, that can utilize this heat energy, some of the energy. So we need to calculate net calorific value. If oxygen is there, we need to subtract, we need to consider only net calorific value. Therefore, then minus 8, where oxygen, percentage of oxygen, already present oxygen. If you have any confusion, you can put like this, plus sulfur, next component, 2,240 into S. So if I give one example problem, you will understand very easily. So I will give one example, one problem. Please just you substitute the values in that formula. Problem 1 for this problem. A sample of fuel, a sample of coal, solid fuel. I'm taking here solid fuel example, that is coal, contains the following. Carbon is equal to 80%, hydrogen is equal to 8%, oxygen is equal to 2%, nitrogen is equal to 2%, and ash is equal to 2%. So here nitrogen is non-combustible. Ordinary conditions, at STP conditions, it does not involve in any combustion reaction. In extreme conditions, that may get converted into nitrous oxide. Ordinary impossible. Now, it is a non-combustible. You can neglect this. So all solid fuels can be burnt in extra oxygen. After complete burning, combustion, the residue left is called ash, useless, no contribution, giving delta H. We are calculating amount of heat liberated, total amount of heat liberated, total amount of heat. CV means gross calorific value or total amount of heat. So neglect it. Your question is calculate gross calorific value CV. This for using that formula, and also net calorific value. What is gross calorific value and net calorific value? Very simple. Just to substitute these values in the formula, you will know gross calorific value. So after that, net calorific value using that formula in previously mentioned formula, the previous class. Using this formula, calculate the net calorific value. So let us calculate gross calorific value. Gross calorific value, just substitute the values in that formula. Gross calorific value of fuel or CV is equal to, is equal to 1 by 100. What is the percent of carbon? 80%. 8080 into 80 plus next 34,500 into what is the percentage of oxygen that we have? 2%. Hydrogen percentage, what is percent hydrogen? 8 minus 2 by 8. So we can calculate value of this plus 2,240 into what is the percentage of sulfur? Sulfur percentage not mentioned is equal to 2. So net calorific of this is equal to around 9,400 calories per gram fuel, or 9,400 kilocalories per kilogram approximately. You can calculate accurately, please. Approximately, right? So you can also calculate net calorific value using this formula. Net calorific value of fuel is called gross calorific value calculated using Dulong's formula minus 0.09 into H into 581. So what is the percentage of is equal to gross calorific calculated 9,400 approximately minus 0.09 into what is the percentage of hydrogen? 8 into 587, right? The percentage of hydrogen, this is the percentage of hydrogen, percentage of 8%. So value may be approximately 7,500 calories per gram fuel, or say 8,750 kilocalories per kilogram. So with this, let me conclude. We'll meet again in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.